in this video we're going to be doing Calc AB Problem Set 104. The problems and a playlist are in the description below. Let's take a look. Given that g of x is the integral from -2 to x of f of t dt and the graph of f shown above. Okay, so find g of 2, g prime of 2, g double prime of 2, or say why they do not exist. Okay, so g of 2 is going to be the integral from -2 to 2 of f of t dt. This is like a geometry problem. So we look, I'm going to cut this into like the triangle that's to the left of the y-axis and then kind of a trapezoid to the right of the y-axis, I guess. So this is, the triangle is 2 by 4 and then half of that. So that'll be 4. And then there's like a triangle that's 2 by 3, which would be 3, plus the little rectangle on the bottom, which is 2, so 5 overall. So this is going to be 4 plus 5, so 9. All right, so that's g of 2. Before we can find g prime of 2, we have to find g prime of x. I think that's an important step, so I'm going to do that. That's the second fundamental theorem. Take the upper bound, plug it in, times the derivative of the upper bound. So f of x times 1. You don't usually write times 1. It is a good idea to write times 1 so that when it's not 1, you like remember to do it, but whatever, doesn't actually make a difference. So then g prime of 2 is f of 2. We have the graph of f, so we just go to x equals 2 on this graph, and that's going to be 1 for sure. And then because at x equals 2, the graph of f is definitely not differentiable. I would say that the graph of f is not differentiable because there's a corner or a sharp turn. If you needed to, you could say that like the slope from the left is negative, the slope from the right is positive, or you could find the actual values. I'm going to choose to say that g double prime does not exist, and my reason will be that g prime has a sharp turn. Also, I never know, like, g prime is definitely f, and I've established that, but, like, I'm never sure if the person reading it is going to be, like, super picky or not, so I'll say g prime equals f, like, every time. All right, so that's part A. Find and classify the critical points of g of x. We already know that g prime is f of x, and so for the critical points, we need to know where f of x, where g prime is equal to 0 or doesn't exist. G prime exists everywhere on the interval we're interested in. So it's really just where g prime, which is f of x, equals 0. And you can see that that's at -2 and 4. So our critical points, I'll just write it down. Critical points are -2 and 4. Now we have to establish if they are, because we have to classify them, right? So we have to say if they're maximums or minimums. Well, at -2, f, which is g prime. So g prime is going from negative to positive. That's a relative minimum. So relative minimum at -2 because g prime, which is f of x, changes negative to positive. And then at +4, f is going from positive to negative, which means g prime is going positive to negative. So g goes increasing, decreasing. That's a relative maximum. So let's write that. So I don't know where I'm right. Oh, g of x has relative maximum at x equals 4 because g prime changes positive to negative there. And that's all you need to do. It's good. That's a good common question. Hopefully you're familiar and comfortable with it. Find the x-coordinates of the points of inflection of g of x and justify. My favorite justification for this is the relative extrema of g prime, right? So g prime is f of x. The relative extrema of f of x are at -5, 0, 2, and 3. So those are going to be the x-coordinates. And my reasoning will be because they're the relative extrema. So those are our x-coordinates of points of inflection because g prime, which is f of x, has relative extrema at those points. Don't get confused at x equals 5. At x equals 5, g prime goes from decreasing to horizontal, like not increasing or decreasing. That's not a point of inflection. That's where you're going, like on the graph of g, you basically go from quadratic to linear. It's like a smooth transition, but it's not a change in concavity, so not a point of inflection. There's a very famous, I don't remember which question it is, there's a famous FRQ where they did something like that, and a lot of people were confused about, are these, aren't they? You have to be going from increasing, decrease, so f prime, the derivative, g prime in this case, has to go from increasing, decreasing, or decreasing to increasing. The derivative can't be going decreasing to constant. It's not a point of inflection. Anyway, what, if any, intervals is g of x decreasing and concave down? All right. So you're going to be decreasing when the derivative is negative, so below the x-axis. You're going to be concave down when the derivative is decreasing. So we need to be below the x-axis and we need to be decreasing. So you can see that that's going to happen here and also here. So I'm going to write that down. So g of x is decreasing concave down on -6, including -6, to -5, not including -5, and then 4 to 5. And my reason will be because g prime is less than 0 and g prime is decreasing on those intervals. So I think that's a good explanation of that. I think that'll get all the points. And let's look at the next one. Same given. Find the average value of f of x. So I had a typo there. I said g of x. You really can't do it for g of x in this particular problem. Find the average value of f of x on -5 to 2. All right, so average value is integral divided by interval. Average value is not to be confused with average rate of change. Average rate of change is algebra and slope. Average value is integral divided by interval. So we have this, and then this is a geometric problem, right? So from -5 to -2, there's a triangle that has a base of 3, a height of -2, so that'd be -6, but half of it. So we're gonna get 1/7, and then this is -3. These are the values we found before, like 4 and 5. So it's gonna be -3 plus 9. So I think the answer here is 6/7. If you disagree, let me know. That's the entire problem set. I hope this was helpful, and good luck.